Welcome back to the lesson on limits, and now we're going to take a look at plenty of examples where we'll learn and practice how to find the limit of various functions at specific points. Now, to start with, we categorize the limits into two major groups. The first group is what we call determinate form limits. So these are limits when the functions are defined at a specific point inspected. I like to call them simple limits because it is very easy to evaluate such limits. All we have to do is sub in the value of x and evaluate. Okay, I hope you can understand my writing here. So here we have x minus 2 over x plus 3. We are trying to check and see what the limit or the value of the function or the estimated value of the function will be at 1. So I first try to evaluate it by simple substitution, obviously, for two reasons. Number one, it may be a determinate form limit, which means that it's a limit that I can determine easily by simple substitution. But if it is not, at least I'll understand the reason why, so I can come up with a way of how to make it determinate. So 1 minus 2 would be equal to negative 1. 1 plus 3 is 4. So I had no obstacles in evaluating this expression or this function at 1, which means that I have arrived to the answer. Negative 1 over 4 is the answer or the value of the limit of this function at 1. Next, we have the limit as x approaches 0, 2 to the power of x. That would be 2 to the power 0. The answer is 1. Now, here is an interesting example, the limit as x approaches pi of sine 1. So as you can see here in the equation of the function, we don't see any x value, which means that there is no spot for us to substitute x by pi. So in this case, we're going to say that the value of the limit will be sine of 1. Now, what is happening in this case? So imagine that you have a calculator, find out the value of sine of 1, and you will see that the value of sine 1 would be some constant number. So even though actually this looks like a very complicated term, it's just a simple little innocent number. It's a positive number because it's a sine of 1 radian, which is about 60 degrees, less than 60 obviously, and it will be a constant number, and the graph will look like this. So if you approach x at any point, so if x equals, let's say, 1, then the value of the function will be sine of 1. If x equals 2, the value of the function is same value, sine of 1. If x equals pi, then the value of the function would still be the same. So we call this the limit of a constant. So the limit of a constant number is the number itself. So next we have the limit as x approaches pi over 4 for 3 cosine 4x, so cosine 4 times pi over 8, x approaches pi over 8, over sine of 4 times pi over 8. So in this case, we have 3 cosine pi over 2 over sine of pi over 2. So cosine pi over 2 is equal to 0, and sine pi over 2 is 1, which means that we have 0 over 1 or 0. So next we have the square root of 2x plus 9 minus square root 5x plus 1 over x minus 4. We're trying to find the value of it at 0. So let's go ahead and substitute x by 0. And down here we'll have 0 minus 4. So that means we have root 9 minus root 1 over negative 4. 3 minus 1 would be a 2. And the answer is negative 1 over 2. And last example, we have the limit as x approaches 3 of number 45. Again, this is very similar to the sine 1 we had before. There is no x in the equation of the function, so therefore we're going to say that the value of this limit is 45.